everybody. Today we're going to be learning about section 6.7, which is on energy from biomass. The learning objective for today is that you can describe the effects of the use of biomass in power generation on the environment. And the essential knowledge that you're going to gain is how burning biomass is going to be used for energy, some of the downsides of this though, and then we'll also talk about some biofuels, such as like how ethanol can be a substitute for gasoline potentially. So we will start with talking about the difference between biomass versus biofuels. Biomass, which I've briefly talked about a couple times in earlier notes in this unit, is just going to be organic matter, such as wood, charcoal, dried animal waste, dead leaves, brush, anything that can be burned to release heat, primarily for heating homes and cooking. This is going to be utilized primarily in developing worlds for heating homes and cooking food because it is easy to harvest, it's available, it's cheap or free, and so it's known as a subsistence fuel because it just kind of like keeps you going at sort of like a basic level. So this would be an example of someone possibly from a developing country that's harvesting palm branches to use for their fire later. Now, biomass can also be burned in power plants to generate electricity, but nowadays this is much less common than fossil fuels, but it technically can be done. So this would be like an example how they have kind of trees or crops that they've mulched, and then that is used, again, for the basics of burning, making that heat, which is going to cause steam, which is going to turn the turbines, which makes the generator, which makes the electricity. Same general process, just using this for heat. But again, this is less common because it's not as efficient as burning fossil fuels. Now, the other thing that we're going to talk about in these notes is biofuels, which is different from biomass. Biofuels are going to be liquid fuels like ethanol or biodiesel that are created from biomass, specifically crops like corn, sugarcane, and palm oil. And these are going to be used as replacement fuel sources for gasoline, primarily in vehicles. So now let's talk about modern versus fossil carbon, which is basically how we get to this idea of like renewable versus non-renewable when we talk about biomass. So biomass burning does release carbon dioxide into the atmosphere, but it doesn't increase atmospheric carbon dioxide levels like fossil fuel burning does. And this is because burning biomass releases what's known as modern carbon. And this is going to be carbon dioxide that was recently sequestered or taken out of the atmosphere. So think of like trees. They're removing carbon dioxide from the atmosphere. They've done it somewhat recently. And then when you remove those, it will release more carbon dioxide, but it's kind of recently been part of this whole carbon cycle. Whereas fossil fuels are going to be when you burn fossil fuels, it's going to be releasing fossil carbon. This has been stored for millions of years in the earth. And so it's not something that was recently part of the atmosphere. It's just going to be adding more carbon dioxide into the atmosphere than was already there. Oh, those went out of order. So another reason that it's considered better than burning fossil fuels is because in order to keep replenishing the supply of biomass, you need to plant more of these plants and trees. So when you plant more plants and trees, that will also remove carbon dioxide from the atmosphere. So this is why biomass burning is technically considered carbon neutral by like our textbook standards, because what's being released into the atmosphere ultimately also was recently taken up and can keep being planted and can keep kind of cycling. So it's technically considered carbon neutral, which you can see from this picture here. The idea of like combustion of fossil fuels is just adding stuff from fossil fuels versus you've got kind of this whole cycling that's going to be happening better with biomass, carbon dioxide. So although it is technically carbon neutral, it does have some human and environmental consequences. The first big problem is that burning biomass is going to release carbon monoxide, NOxes, particulate matter, and VOCs, volatile organic compounds. All of these are respiratory irritants. Now, if you think of the fact that 3 billion people globally cook on open biomass fires, mostly in the developing world, be aware that when you burn biomass indoors for heating and cooking, this really worsens the effects of all these respiratory irritants because they're trapped in a building. And so this is going to lead to worsened asthma, bronchitis, COPD, emphysema, and eye irritation. So if you imagine, this is what it typically looks like when it's heating and cooking. It's inside a room that's trapping all of those irritants. Now, some environmental consequences of using biomass for burning is going to be deforestation and air pollutants. So, because there is a lack of environmental protection laws and financial resources for other fuels, this then is going to lead, specifically developing countries, to have more deforestation in order to have these fuels for cooking and heating, because there are not often other infrastructures. So the more you have the population growing, the more trees are getting cut down, the more deforestation is going to be happening. So you're going to have habitat loss, soil erosion, loss of carbon dioxide sequestration. And then also, because we have these plants and trees filtering air pollutants, you now are going to lose that air and water filtration as well. Sorry, my dog's making an appearance in this video. Now, additionally, when we burn these things, you're going to have the NOxes, the VOCs, and the particulate matter all contributing to smog formation, which is going to have air pollutants increasing. So now let's talk about biofuels, specifically ethanol and algae. Now, corn and sugarcane are fermented into ethanol when mixed with gasoline. So you can have corn. Let me restate that last sentence. Corn and sugar are fermented into ethanol. Ethanol can be mixed with gasoline. Okay, so if you think about yeast, anaerobic, alcoholic fermentation, which maybe you learned about in biology, this is going to be where you have the corn grain and sugar broken down, the yeast is fermenting it, it releases ethanol through this process. Now, you can have an entire production system for this, just like we have production systems for using yeast fermentation for alcohol production. So you can use that ethanol, mix it with gasoline, and it makes something called flex fuel, or E85. This is where it's going to be about 51 to 83% ethanol mixed with the gasoline, and this can be used in flex fuel vehicles. It has to specifically be a vehicle that is meant to take this in. If you just go and drop this in your regular car, it will destroy the engine. But if we have these flex fuel vehicles, which are out on the road, this is going to make it so that you can decrease the oil consumption for transport. But the downside is this flex fuel is less efficient than pure gasoline. Now, it is considered a renewable source because you can keep planting this corn and sugar in order to renew it. However, it's only renewable to the extent that the production of corn is going to be sustainable. Sugarcane is a perennial and it's more sustainable because it's just going to keep growing every year and you just harvest and it keeps going. But remember that corn, you've got to have this whole process of like replanting the corn, tilling it, replanting it. So the corn production has to keep up with the ethanol production. Otherwise, it's not going to be very sustainable. Now, some environmental consequences that can come from this are going to be all the negative consequences of monocrop agriculture that we talked about in Unit 5. So it can lead to soil erosion, habitat loss, greenhouse emissions from the tractors and the fertilizers, and it's also going to require a lot of water use. There's also going to be lots of corn that is needed relative to petroleum. So because it's less efficient, you need more of it because you're going through it faster. And so this is then going to need more and more corn, which again, then we bring in all those Unit 5 monocropping issues. But we also are now potentially going to be competing with the human consumption of corn because corn is used in a lot of things that we need to eat. So now you're trying to grow a bunch of corn, but it's taking up land that could be for feeding people. So that can run into potential problems. Now, there has been a lot of really cool science done recently where people are using algae in order to create more sustainable biofuels because these algae produce oils that can be used as biofuels. And so, this process, if we can continue building on it and make it a better system, this could theoretically in the future be much more sustainable than corn. And this is just like a diagram of how you're going to have the algae growing and harvested, and then you can use the oils to convert it into a um, biofuel. All right, biodiesel. These are going to be liquid fuels that are produced specifically from plant oils from soy, canola, and palm. Palm oil biodiesel, however, has been found to produce 98% more greenhouse gases than fossil fuels because of their production. So, specifically because of the fact that forests have to be cleared in order to plant palm plantations. And so, because you are taking out forests in order to make these palm plantations, overall it's going to produce more greenhouse gases, um, which theoretically, if you have an area of land that's already been cleared and then you're planting those plantations in only those places, this could be more sustainable than clearing out forests for palm oil, like is currently happening. However, keep in mind, we still have all the negative impacts of agriculture, but we're at least not losing so much of the forests if we do it that way. So this is going to be an example of what a palm oil area can look like. So we're getting carbon dioxide release, we're losing habitat, soil erosion, air filtration, all of those negative agricultural impacts that we learned about in Unit 5. So this is going to be your practice FRQ for 6.7. I want you to explain why biodiesel fuels have a different effect on atmospheric carbon levels than fossil fuels do. And then I want you to describe 2 environmental benefits of using algae for biofuel production rather than corn, palm oil, or sugarcane. So that is your practice FRQ for 6.7. And that was your notes on 6.7 about biomass and biofuels.